And then I want to look at the difference quotient, another problem. What do I need to write? What condition I need to write and solve to find the domain? Anyone remembers this? Sorry. Anyone remembers how we define the domain of a log function? No one remembers this? Very simple. It's 1 minus x greater than 0. Negative x greater than negative 1 less than 1. That's it. That's the domain. We cannot apply log to negative numbers or 0. What about a function to determine its difference quotient? Is this okay, or you remember that?
Okay with reviewing that.
Okay, so let's say negative 3x squared plus 2x minus 1. And the difference quotient, you must remember that it's f of x plus h minus f of x divided by h. And these are clear, but this one is not. So I have to work on this on the side. How do I write the initial step that later on I'll simplify? What is the initial step?
Well, you have to plug
X plus
it
h.
in.
Yes, I have to plug it in, and I will write initially negative 3, and in parentheses x plus h squared plus 2x plus h and minus 1. Now, remember, I have to square first. Do not try to distribute till after you square. And when we square binomial, we know that we get how many terms?
Two terms.
Say it again.
2 terms.
Never. Please, I'm begging you. Please make a note. Put it on your formula sheet, on your notes. A binomial squared is always 3 terms. Please, don't make me cry. Please, please, please. So it's very easy to confuse. I understand. It's very easy to confuse this, which is this, to this, with this. But this is 3 terms. So when it's a product, it's a different situation. When it's a sum, we have to get 3 terms. And that's how we get that x squared plus 2xh and plus h squared. So write it down on in your notes. So plus 2x plus 2h minus 1. Only now I can distribute. And be very careful, we have to distribute to all 3 terms. So negative 3x squared, minus 6xh minus 3h squared plus 2x plus 2h minus 1. Now, only now, I can write the whole thing over h. So I copy all this as negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h minus 1 minus the original function, which means positive 3x squared minus 2x and plus 1. And you have to remember what needs to happen, which is absolutely mandatory. All terms without h must go away. If some terms with h go away, it's even better. But definitely those with no h must go away. And now we have 3 remaining terms. They all have h in common. So I have to factor out h. So I factor out h. So then I can simplify with the h in the denominator. The final answer should still have h in it, but not this one from the denominator. So we have negative 6x minus 3h and plus 2. Sorry, I squeezed it in there. Negative 6x minus 3h and plus 2. So please make yourself a note on a binomial squared is 3 terms, please. Good. Next question. Any questions? Anything else that we want to look at?
Can we look at some sequences from chapter 5?
Yes, of course, absolutely. Let's see the page number. It's basically chapter 8. So page number 756. Very good. Yep. Anything. I'm looking to see what they have for the review. Maybe they have something more interesting in the review. Yeah, maybe, yeah, 831. And we can come back. So here at the bottom is just a review of 8.1. That's all we studied in chapter 8. See if anything catches your eye.
Can we do number 6?
Yes, it's number 6. So in number 6 on page 831, we have a1 equals 4, a sub n equals 2, a sub n minus 1 plus 3 for n greater than or equal to 2. So they want us to find the first 4 terms. The first term is already given to us. So then a1 equals 4. a2 means 2 minus 1. So 2 times the previous number. I meant to write 4, but in my mind I already calculated. Plus 3. So this is a sub 1, 2 times a sub 1 plus 3, and a sub 1 is 4. So 2 times 4 plus 3, 8 plus 3, 11. A sub 3 is 2 times the previous one plus 3. 2 times the previous one plus 3, 22 plus 3, 25. And the last one is 2 times the previous one. That's the pattern we have, the recursive relationship. 50 plus 3, 53. So the first 4 terms of this sequence are 4, 11, 25, 53. Good. Good. Next question.
Can we also do number 7?
Yes, of course. Number 7, evaluate. Good. In number 7, we have 40 factorial over 4 factorial times 38 factorial. This again is an easy situation. Why? Because I look at these two numbers and they're pretty close. I can only work on the big one and stop at the smaller one and simplify. Now, what is 4 factorial? It's 4 times 3 times 2, the 1. Okay, so 24, right? But it's better to write it like this. Here's why. So I have 40 times 39 at the top, and the denominator is 4 times 3 times 2. A 10 and a 5 and a 3. So the whole thing is just 5 times 13, which is 65. Sometimes this can be handled by the calculator, but sometimes it cannot be. So the simplification is the only way, but we can always try. So factorial is in the math and probabilities. So 40, math, scroll to the right to probabilities, and then down to number 4, and divide in parentheses, please, 4 factorial multiplied by 38 factorial. Okay? Don't forget parentheses around the denominator. If you don't put parentheses around the denominator, the calculator will divide 40 factorial by 4 factorial, and the answer will be multiplied instead of divided by 38 factorial. So when I click enter, if it can handle this, it will give us 65. If it cannot handle that, then it will get an error. So when the numbers are too big, we will get an error. The calculator does, has limitations. Good. Let's also look at number 8. In number 8, we have the sum from I equals 1 through 5 from 2I squared minus 3. So it is best to present the terms of the summation notation and not calculate them by hand, just use the calculator. But we have to present them. When I is 1, 2 minus 3 plus. When I is 2, 2 times 4 minus 3. Oops, plus. When I is 3, 2 times 9 minus 3. Sorry about that. So where was I? 2 times 1 minus 3. 2 squared. 2 times 4 minus 3. Now 3. 2 times 9 minus 3. Now 4 plus. 2 times 16 minus 3. And plus, last one, 5. 2 times 25 minus 3. And now we will put this in the graphing calculator. Here it is. And it's in math, and go up to 0 and enter. So from x, we don't have I, j, k, from x equals 1 to 5. And careful how you enter this. So it's 2x squared and minus 3. So when I click enter, I should get the sum of all these, 95. Of course, you can check. So this is -1. This is positive 5. This is 18 minus 3, so which is 15. This is 32 minus 3, which is 29. And this is 50 minus 3, which is 47. Okay. So this is 20. This is 76. So this will be 96, and minus 1 is indeed 95. So it's not such a big deal, but you can use the calculator, but you have to list the terms. Calculating them or not, it's okay. Good. Next topic or next question?
Can we do f comp of g?
Yes, very good. Very good. So here's an example. Do you have an example or do you want me to make one up?
Can you just make one up?
Okay. So let's say negative x plus 2, and this is x squared plus 2x minus 3. And let's say we want to find f comp g of x. If I'm asked to find f comp g of x, first I have to write that f comp g of x is f of g of x. Then I have to write that it's f of negative x plus 2. Then I have to plug it in. And when I plug it in, I get negative x plus 2 squared plus 2 negative x plus 2 minus 3. Again, how many terms we get when we square binomial? Anyone?
3.
Yes, 3 terms. The first term squared minus 2 times the first times the second plus the second term squared minus 2x plus 4 minus 3 x squared minus 6x 8 minus 3 is positive 5. This is f comp g of x. Good. Anything else?
We do a piecewise function.
Yes? Do you have one in mind? You mean graphing it?
Yeah.
Do you have one in mind?
No, I didn't have one.
Okay, so I will make one up. X squared plus 1 for x less than or equal to 1, and 2x minus 4 for x greater than 1. So the starting point should always be changing this into a interval notation. Why is this so important? It's because of that threshold point, which is at 1, with a bracket to the left and the parenthesis to the right. This is the key step here. And then writing on top of the table that from negative infinity to 1, you have to use x squared plus 1. And the other one, although the function can have 3 or 4 branches. I chose simple examples with 2, but you can have more than 2. Okay, so when I plug in 0, I get 1. When I plug in 1, I get 2. When I plug in 1, I get negative 2. And obviously, I'm going to choose 2 because it's the x-intercept. That's all you need, basically. Or you can also put a -1, and -1 plus 1 is also 2. So, because we know how to graph this, it's x squared up 1. So, using transformations. Now you have to be very careful. The two branches can never overlap. This one is only here, this one is only here. So, -1, comma 2, 0, comma 1, 1, comma 2. And this is it. You cannot extend because this graph is only between -infinity and 1. This is it. Done. I'm going to use a different color. You don't have to do this on the test, but I'm making a point. 1, -2 is here, and it has to be an open point. This is an open point. And 2, comma 0 is this, and this is a straight line. Make sure that by the vertical line test, this is a function. Because if I continue here and I continue here, I won't get any points. Because it's an incorrect graph. And if the problem is asking us about the range, obviously from -2 open to infinity. So -2 open to infinity.